Alright, so there's a lot of people out there that think that silver tarnishes and that's a bad thing. That's a myth, and I don't know who started it, but let's clear it up. Okay, you already know, or you should know, that silver is the most electrically conductive element known to man. Of all the ones we found, that's it. So, that's nice, but people don't like it in comparison to gold because it develops a black kind of film on it over time. Now, that's not like rust. There's a lot of people that have this misconception that it's going to deteriorate and disappear. That's nonsense. If you want to look up the Egyptians, the very first Egyptian sarcophaguses were actually made of silver, and they still find them today. So it doesn't rust, it doesn't disappear. All that happens is usually the tarnishing that you're going to see is based on sulfur. Sulfur is missing 2 electrons in its outer shell, and silver has an extra 1 in its outer shell. So if you take 2 of those, 2 silver atoms, they're going to attract a sulfur atom, and there you go. It looks black, and it covers the outside of whatever silver that you had. The pure metal would just cover it in a black coating, and that's it. If you want to reverse that process, it's a chemical reaction, so you can chemically reverse it and make those silver cells that were holding on to a sulfur, get rid of them. So there's no loss of the metal, so to speak, when you have tarnishing, as long as you reverse the process chemically rather than grab a cloth and try and rub it off, because that will take off the top layer of silver atoms, and that will eventually, you'll have a little bit less metal. We're not talking a whole lot, but still, it's better to chemically reverse it than it is to physically reverse it. But something that you may not know is that the least electrically conductive element, or the best insulator of all the elements in the table, is sulfur. Okay, that may seem ironic that the most electrically conductive element automatically wants to bind to the least electrically conductive element. And silver sulfide is very common in use for all kinds of industrial applications, from solar cells to, because it does form a semiconductor, is what it does. When you have something that really does conduct electricity and something that doesn't, you put those two together, if you can get them to go together, which silver and sulfur do. Now, obviously, because sulfur has such a low melting point, it's used in gunpowder and things like that, you wouldn't want to use this combination, silver and sulfur, in something that had a high temperature, because it would catch on fire. But for low frequency things, very low frequency and low voltage applications where the temperatures are not going to exceed 293 degrees Fahrenheit, you could. So tarnishing silver is simply the silver protecting itself and insulating itself. That's all it is. That's all the tarnish is. So this big hype about, oh, it's going to tarnish and look like, you're missing the point there. That's actually a benefit to the material. It's something that gold doesn't do. It's something that gold can't do. So again, think about a wire. If you took a wire and exposed it to sulfur, you would have a self-insulating wire, right? So again, tarnishing of silver is a chemical reaction. It's not a physical change. Iron, if you took iron, the element, and exposed it to what it reacts with, oxygen, water, that kind of thing, it would oxidize and turn into rust. And it's actually a different element. So you'd have a big pile of rust. You wouldn't have an iron center, an iron statue with a nice covering over it. You'd end up with a pile of dust. So it's completely different. One last note. There are a lot of people that say that they produce silver. They're silver producers. This is another falsehood. No one produces silver. The amount of energy required to produce silver, and you can produce silver. You can produce gold for that matter. The way that process works is you take iron, the element iron, it's got to be in a star somewhere, and it can't just be any old star. Like our sun's way too small to make silver or gold. Way too small. So you take the iron core. When the star collapses, called a supernova, when the star collapses in upon itself, the pressure in the center of the star, right before it explodes, is a lot of energy. And what it does is it takes the iron atom and bombards it with a whole bunch of neutrons, so that it makes the iron atom actually, here, oh, it's got more stuff. Then protons, bombards with protons. Once the protons expand the cell, protons decay into neutrons, and, however many were in there, once it reaches a stable rate, which would be the element silver, also gold, if it had a lot more shoved into it, and then they decayed, the gold would form. You end up with those elements. Silver being 47 protons and 60 neutrons. The point is that the amount of energy required to create or produce silver is about, to give you an idea of size, if you took our sun, the Earth's sun, and all of the energy that it puts out over 10 billion years, and condensed that into a millisecond, that would give you enough energy to create silver. So anybody who says they produce silver is full of it. They're finding it. That's all they do. They find silver. Okay, that's it. So I guess one more thing we should clear up is also this idea that because the photo industry is not going to use it for developing film as much, there's not going to be as much film developed, that the demand for silver is going to be less. It's totally false. They're missing a really obvious point here, and I can't believe that people even make this argument. But the pool of silver that the photographic industry was using is all based on a supply that they have, because they recycle almost 90% of what they get. So there is a net demand from silver photography for sure, but it's small. It's like 46 million ounces, or maybe anywhere from 46 to 96 million ounces is all that they actually demand every year. So that's really minuscule if you contemplate the fact that what are people taking the digital photographs with, right? They're using cell phones, okay? Cell phones or digital cameras. Silver goes in there, into the actual camera or into the actual phone, in the form of solder, in the form of circuit boards, in the form of, diodes and switches. It's in the actual thing that's taking the image. So yeah, you don't have as much being used to develop pictures, but you're using it to take the pictures. So that's going to be a non-issue as far as the demand for silver goes. And anybody who makes that argument, explain the other end of that. How do you account for a billion phones that are all going to use silver? Whereas before, the SLR cameras that people would use to take the pictures, there was no silver in the camera. Right? I mean, yeah, the film that went in the camera, sure. And to develop the film, sure. But it's not in the camera itself. Now, it's in the camera. Now the camera has it. And then we use digital to produce the prints. And there is still some silver being used in prints anyway. So it's a ridiculous argument. Not to mention the fact that actually that big use by the photography industry served as a pool of silver, just like the Comex does, or the SLV, all of those. It served as a pool of silver that was available should it be needed. Okay? I mean, so if something of a priority came up that we needed silver for, like power generation or computers, right? I mean, you want to have a computer, you're going to have a circuit board. So anyway, the point is that silver could then be, squeezed, price of film would go up, they'd make it more expensive on their end, which reduces the amount of pictures that are being done, which would then make up that amount of silver available for other industries, or to cover the shortage. And as that shrinks, the elasticity of the price of silver is going to get even more pronounced. So instead of little $3, $4, $5 swings, you're going to have $10, $15, $16 swings. So, again, something to think about. But sulfur, the most electrically non-conductive element, pairs with silver, the most electrically conductive pair. Interesting.